Okay, welcome to, gosh, I guess another video here on how to do these group problems for contextualizing quadratic functions. So I don't know, maybe I should say as we get going here that some of these might seem relatively simple, but the reason I'm taking the time is I really want to communicate to you guys how to interpret this stuff and the best, kind of the best way and the expectation for, to communicate your results on an exam. So, and keep that in the back of your mind. That way, when test time comes or labs come, you can communicate these things effectively, and then you also be successful with your next instructor, so to speak. So, take a look at this problem. I'm not familiar with, I don't know if I'm saying it right, amaranth. I guess it's the plant that's grown around the world. Some are weeds and some are leaves and seeds that people eat. And there's a function there. This is when plants are grown in rows, the height that the plants attain, in other words, how tall they are. Notice that's labeled already as the y here, and we'll see if I can get my pen working. So that's the plant height in centimeters. So y is going to be height. Notice I'm not even done with the problem. I'm labeling things, so get in that habit if you can. And x is the number of centimeters between. I'll just put BT. But that really is between the plants here for the x-axis. So if you're looking at this thing, let's continue where it says when the amaranth plants are grown in rows, the height of the plants attained is a quadratic function, which is what we've been working on, of the spacing that's between the plants when you're within the row. So there's a little picture there for you. And you have a function here. And notice, if we haven't mentioned it already, that the coefficient here in the front, that's positive. So this is going to be concave up. So I always say CU, but in other words, it's a smiley face. And I'm just being silly. But the result of that, though, when you have a concave up function, is that you're going to have a vertex down here somewhere. And then x-intercepts or y-intercepts, we can look at those on an as-needed basis. So, okay, so you've got some function. And notice, before we even get to questions, it looks like the number of centimeters, if the number of centimeters here, whatever that might be, and we can estimate it to be approximately, I don't know, what's your best guess? 27 comma maybe 16. So if we do that, then your height of the plant at 27, now notice how and this will be the question for you later, I want to know what stuff means. So at 27 centimeters between plants, that's the x, right? That the height here of the plant will be 16 centimeters. And it looks like if there's more space as you go left or right here, more or less space, that the plants will actually grow bigger. So it looks like if there's more space between the plants, they'll grow up to almost 40 centimeters. And then if you also lessen the space, which almost, I guess, makes them a bush, then you'd also get some height here, so to speak. Now, being a bush, I kind of think of it like this. But if you plant them with no space in between, that would be the point here, which is 0 comma something. And that's actually the first question. It says estimate the y-intercept. If I'm estimating, that looks like 30, I don't know, right in the middle maybe. 32.5, I don't know if I'm estimating. But the faster way, it says do it with the more precise way or your calculator. And really, we don't even need our calculator for that one. All we have to do is plug 0 in for x into our function here and here, which in effect, 0 will take that out and it'll take this out. Uh-oh, well, that means this is my actual y-intercept. So that 32.2544 is my actual y height. And as I back out of what I've just previously written, see how far we can go here. That real answer is 33. Oops. Let's just keep going. My computer starts to jet here. So that real answer is going to be 33.2544. So 0, 33 if you're taking notes, 0.2544. And if I were to ask you again, the number on the test is going to be worth, I don't know, just as much as the explanation. If I say, what is the meaning? Notice that's here. You're going to say at 0 centimeters, between plants. Now notice that's just this X value. All I'm doing is taking that and plugging 0 and talking like this, 0 numbers or the 0 centimeters between the plants, the height, oops, can't spell yet. Height of my, whatever they call it, amaranth. I'm saying it wrong. Amaranth. The height of the amaranth, I'm not going to spell that all. Is going to be 33.2544, and I'm just being lazy. But notice this is the X value here, and this is the Y value here. I'm just attaching what the labels are, and hopefully you're catching on, because every problem might seem terrible, but all I'm doing with every word problem is I'm labeling my X and Y. Notice at top here, X and Y, what those are, my variables. And then if I have a point, I'm just saying X is the Y, whatever the X is, and the Y is the Y, whatever Y is, in this case, the height. So if I had to estimate the vertex for 3, kind of already did that and talked about that too, didn't we? So at a 27 centimeters between plants, and I'm again looking right here, then you will have a height of 16 centimeters. Okay, so 3, you can actually plug this down here. We've already done that. And what that just means, well, think about it. What would you say? Notice this is a meaning question that's worth points on a test. This is a meaning question that's worth points on a test. What would it mean? Not 27 comma, excuse me, 16, but what does it mean? And hopefully you're saying if you put 27 centimeters between the plants, your minimum height, notice this is a minimum value because at the bottom of a vertex, the minimum height, so here's what I would write, at 27 centimeters, or approximately, right, between plants, that's the X value, the height of, again, I can't even say it, was it amaranth? The height of your amaranth is minimized at 16 centimeters, I think. Okay, so does it make sense for part 5 there then? And I should remind you before I move forward, if we really wanted to find out the exact answer, X equals opposite of B over 2A would give me, I don't know if it's 27 or not, but it should be close. So for those of you at home, if you really wanted to answer this question, you could say X, I know I'm right in the wrong spot, but my B would be, minus 1.278. All over 2 times whatever my A is. And again, I won't do it here. You guys can crank it out, but 0.0237. Okay, so crank that out, see what that is, and it should be pretty close to 27. Now, back to number 5, does it make sense that the function has no x-intercepts? Well, you tell me, what would happen if you would have an intercept here? That would mean that you would have no height if the plants are, I don't know, 15, 20, 10, 15, 20. So, I mean, if you had an intercept, it would mean you'd have no plant. So yeah, it makes sense in this problem. If I were answering them, yes, it makes sense. So does it make sense? I'd say yes. Because at that value, your plant you couldn't see the plant. It would have no height. So that's really all I'm asking you to do on this one. And you can, for practice, if you want, go ahead and practice graphing that on your calculator. Notice if I cheat here a little bit, that my x-axis goes from 0 to 55, and my y-axis, I'm counting by 5s, from 0 to 45. So let's go ahead and practice that just real quick. I'm not trying to waste your time. I've already entered it in here. But sometimes, if I haven't said it already, when you just graph things, your graph, especially if you're using somebody else's calculator, graph's not going to come out too hot. So one trick I always tell people is to hit zoom and go here to standard And all that does, it goes to a 10 by 10 viewing window. So notice you can't say anything, but that's just 10 to negative 10 and 10 to negative 10. And that's your standard window. And you can see that over here if I stop annotating. And it'll go from 0 to 0. Okay, so if I take that off, and I'm not seeing any graph. Sorry, as I bounce between the technologies here. But if I click on my window, remember what we're going by 5? So you can go from negative 10. Let's go to 70. Our graph on the paper only went to 55. But the scale this time, let's let it be 5. So we're going to count by 5. The Y minimum we can leave. Notice my Y max was 45 in our example. So maybe I'll go to, I don't know, 100. You can't really get it wrong. I'm going to count by 5s. You really want a viewing picture that just allows you to interpret and answer the question that's being presented to you. Okay, so let's grab it. I should get something very similar to what we looked at before. And guess what? It looks just like what we were messing around with, which is, I don't know why it's not switching over. I can't get back to it, but let me try it this way. So that should be just like that. Okay, so there's your explanation on the last problem here. Good luck on doing your lab. And if you have any questions, of course, get a hold of me. Take care, guys.